students, welcome you all to Think Max. We are in class 11 Max, chapter 2, Relations and Functions. In this session, we are going to discuss about the relations. So, in relation, we will discuss the basic concepts, that is introduction and the examples related to this relation. So, we will discuss examples 7, 8, 9 in this session. Okay. So, first let us know what is a relation. So, what is a relation? A relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product A cross B. So, a relation will be defined between the non-empty set A and non-empty set B. So, that relation will be the subset of the Cartesian product A cross B. Okay. So the subset is derived by describing a relationship between the first element and the second element of the ordered pairs in A cross B. So how will be the relation? The relation from the first element will be related to the second element. That is, the element in A will have a relation with element in B. Okay. So that is called the relation. Now let us understand this with the example. So let us take A is equal to 1, 2, 3, 5. B is equal to 1, 4, 9, 10. So non-empty set A and B are defined. Now we have to find out the Cartesian product. So what is the Cartesian product? We have to pair every element of A with every element of B. So how we will be pairing? We will take the element from A and pair with all the elements from B. So here A cross B means this is the ordered pair. Okay. So ordered pair is written inside curved bracket. So start with the set bracket and write the ordered pairs inside the curly bracket. So how to write the ordered pairs in the curly bracket? We have to take the first element from A and the second element from B. So now we have to take all the ordered pairs. So how will we do it? So we have to take the first element. So 1. So what we will do? We will pair all the elements with B. So it is 1 comma 1, 1 comma 4, 1 comma 9, 1 comma 10. So this is the pairing with the first element from A. Okay. So 1. Next take 2 and pair it with all the elements from B. So it is 2 comma 1, 2 comma 4, 2 comma 9, 2 comma 10. In the same way, take the next element, it is 3. So it is 3 comma 1, 3 comma 4, 3 comma 9, 3 comma 10. Next take 5 and pair it with 1, 4, 9, 10. So 5 comma 1, so 5 comma 4, 5 comma 9, 5 comma 10. So this is the total ordered pairs for A cross B. So if you do it in an ordered way, you will not miss any ordered pairs for the Cartesian product A cross B. Now what is a relation? It is a subset of the Cartesian product. That means there will be some elements from A cross B. That will be the relation. Now let us define the relation. Okay. So let us define the relation as or such that relation from A to B, which is equal to set of all x comma y such that y is equal to x square, where x belongs to A and y belongs to B. So how is the relation defined? The value of y should be the square of x. Also the y should belongs to B. So what are they? So now let us write the relation R from A to B is nothing but set of all. Choose the element from X. Okay. So X belongs to A. Take A, which is 1. So what is the square of 1? It is 1. Is 1 is in B? Yes, it is in B. So we can write 1 comma 1. Next take 2. What is the square of 2? 2 square is 4. Is it in B? Yes. Next take 3. What is 3 square? 3 square is 9. So it is in B. Next take 5. 5 square is 25. Is 25 in B? No. Here x should belongs to A. Yes, x belongs to A. 5 belongs to A. What is 5 square? Because y is equal to x square. So y should be the square of x. 5 square is 25. 25 is not in B. So this ordered pair will not come. So we have to stop with this. So this is the relation. So the relation has the elements 1 comma 1, 2 comma 4, 3 comma 9. So this is the answer for relation from A comma B, which is nothing but set of all x comma y such that y is equal to x square. Here if we take y, x is equal to 5, y is nothing but x square. So which is 5 square. 5 square is 25, but it does not belongs to B. So we cannot take 5 comma 25. Okay. So therefore these are the ordered pairs for the given relation. So here if you check this 1 comma 1 is in A cross B, 2 comma 4 is in A cross B, 3 comma 9 is also in A cross B. So we say it is a subset of the Cartesian product. So this subset, how we got this subset, is derived by describing a relationship between the first element and the second element of the ordered pairs in A cross B. So this is what the definition of relation. Okay, understood? So you can write relation from A to B is a subset of A cross B. That is, all the elements, all the ordered pairs in this relation will be present in A cross B. So, if this condition is satisfied, the relation from A to B is a subset of the Cartesian product A cross B. Okay. So, I hope you can understand the basic definition in relation. In the next page, we will discuss about the domain, codomain and range, which will be discussed in the next page. So here I took the same example. That is, set is A is equal to 1, 2, 3, 5. B is equal to 1, 4, 9, 10. So this is the Cartesian product formed between A and B. The relation is defined as set of all x comma y such that y is equal to x square, where x belongs to A and y belongs to B. So with this relation, we will get R such that A is from A to B, set of all 1 comma 1, 2 comma 4, 3 comma 9. So these relations we will get. Now we have to define the range, domain and codomain for this relation. So what is a domain? Domain is nothing but first elements of ordered pair in relation. Okay. So what is the relation? It is nothing but y is equal to x square. So this is the relation defined. We have to take the first elements of this ordered pair. Okay. So the domain is nothing but, what are the first elements? No curly bracket. What are the first elements? 1, 2, 3. 1, comma, 2, comma, 3. So this is the domain. What is range? Second elements of ordered pair in relation. So what is the second element? 1, 4, 9. 1, 4, 9. Okay, this is the second element in relation. Okay, you have to take the first element and second element from the relation for domain and range. Okay, what do you mean by codomain? Codomain is nothing but all elements of second set. What is the second set? Second set is B. So it is nothing but 1, 4, 9, 10. all elements of second set, which is nothing but B. So this is codomain. Set B is the codomain. So these are called domain, range and codomain. Okay. So if we take the relation, this relation can be represented in three forms. So this form is set builder form. So one of the form is set builder form, and if you write the ordered pairs, it is called roster form. Okay, so we can represent the relation in set builder form. Another form is roster form. One more form is using the visual representation, that is arrow diagram, which we will discuss in the next page. So arrow diagram. The same example with the set A is equal to 1, 2, 3, 5. Set B is equal to 1, 4, 9, 10. So this is the Cartesian product between A and B. And the same relation is defined. Y is equal to x square. And here x should belongs to A and y should belongs to B. So we got the ordered pairs for this relation. It is 1, 1, 2, 4, 3, 9. Now we have to form the arrow diagram. So to draw arrow diagram, what we need? We need a oval shape. Okay. This is the basic thing. So this is the set A. So in the set A, what we have? 1, 2, 3, 5. So draw an oval and write the elements of A. Now take another oval shape and write the elements of B. 1, 4, 9, 10. So these are the elements of B. Now we have to show the relation with arrow. So what is the relation? It is 1, 1. So from 1, which is in A, you should draw arrow to B, okay, which shows 1. Okay. So this is the first relation. Next one is 2, 4. So 2 from A and 4 from B. So draw an arrow between this. Okay. Next 3, 9. So draw an arrow between 3 from A and 9 from B. So this is the way to show the relation in arrow diagram. Okay, children? Understood? So take two oval shape. One is set A and another is set B. So write all the elements of set A and write all the elements of set B inside the oval. So we have to mark this ordered pair using arrows. So 1, 1. From 1 from A and 1 from B, draw an arrow between this and 2, 4. So 2 from A and 4 from B. So draw an arrow between this 3, 9. So 3 from A and 9 from B. So draw an arrow between 3 and 9. So this is the way to represent relation in arrow diagram. It is nothing but visual representation. So this is called visual representation of relation. Okay, arrow diagram is called visual representation of relation. Understood? So now we will take some points. So what are the points to be noted in relation? First one, the total number of relations that can be defined from a set A to a set B is the number of possible subsets of A cross B. So how many relations can you form with the set A and set B? Okay. So it is nothing but, if suppose number of elements in A is P and number of elements in B is Q, then number of elements in A cross B is nothing but its product P and Q. P into Q. So it is PQ. Number of elements in A cross B is PQ. So the total number of relations will be 2 to the power PQ. Okay. So this is the formula. So let us understand this with an example. Suppose A is equal to 1, 2 and B is equal to 3, 4. So how many elements in A? 1, 2. There are 2 elements. How many elements in B? There are 2 elements. So number of elements in A cross B is P into Q. That is 2 into 2, which is equal to 4. What is the number of elements? Number of relations. So number of relations, which is equal to 2 to the power PQ. Who is PQ here? Product of this is 4. So it is 2 power 4, which is 60. So there will be 16 relations. Okay. For the set A is equal to 1 comma 2 and for the set B is equal to 3 comma 4. So we can find out 16 relations between these two sets. Understood? Now, if it is a relation between the same set A, that is a relation R from A to A is also stated as relation on A. So, if we form the relation between the same set, A is equal to 1 comma 2 and A is equal to 1 comma 2. So, if it is so, suppose I define a relation R such that set of all x comma y, okay, such that y is equal to x plus 1. Y is equal to x plus 1 and this x should belongs to A and y should also belongs to A. Okay. If both the elements are from A, then it is called relation on A. So what are they will be? This relation will be from A to B, which is equal to, if you take an element from A, it is 1. So 1 plus 1, 2. So it is 2. If you take 2, 2 plus 1 is 3. It is not in A. So the only relation is 1 comma 2. So this is the answer for the relation from A to A. Because in A we have 1 comma 2. So the relation is y is equal to x plus 1. So if I take 1 and add 1 with this, we will get 2. Okay. So y is equal to x plus 1. If you take x is equal to 1, okay, x is equal to 1, y will be equal to 1 plus 1, 2. It also belongs to A. So we can take this ordered pair 1 comma 2. Next, what is the element in A? It is x is equal to 2. So y will be 1 plus 2. 1 plus 2 is 3. 3 is in A? No. So it does not belongs to A. So we cannot take this ordered pair. So the only ordered pair is 1 comma 2 for the relation defined y is equal to x plus 1. Okay, understood? Next point, a relation may be represented algebraically either by the roster method. So in algebraically, we can express this. That is, in mathematical form, we can express them in roster method or set builder method. So this is the set builder method and this is called the roster method. Roster method, we will write all the ordered pairs. Okay. So this is called the set builder method, which shows the relation in variables. So this is set builder method and roster method is this one. Okay. An arrow diagram is a visual representation of a relation. So visual representation is arrow diagram. That is how we should draw the arrow diagram. Draw two oval shapes. Here, if you take this relation on A, both are 1, 2. So what we got the relation? How many ordered pairs? It is 1 comma 2. So take 1 from this and mark to 2. So this is the only relation. Okay. So this is the way to show in a arrow diagram. Okay. Understood? Okay. So I think with this, all the basic concepts involved in relations are completed. Now we will discuss the example problems related to relations. Okay, children? So let us discuss in the next page. Example 7. What is that? Let A is equal to set of all 1, 2, 3, 4, 5, 6. Define a relation R from A to A. There is a relation on A by R is equal to set of all x comma y such that y equal to x plus 1. What we have to do first question is depict this relation using an arrow diagram. Write down the domain, codomain, and range of R. Okay, children? Now, first let us use the arrow diagram to show. So, to show arrow diagram, we should find out the ordered pair for this relation. So, what is the relation? They gave the relation in set builder form. So, let us convert this set builder form to roster form. So, R is a relation from A to A. So, first element should be from A. So, it is 1. I took 1. So, let me define here x, y. What is y? It is x plus 1. What are the elements in x? It is 1, 2, 3, 4, 5, 6. Y is equal to x plus 1. So, y will be equal to 1 plus 1, which is 2. Yes, it belongs to A. Next, for 2, y is equal to 2 plus 1, which is equal to 3. Yes, it is in 3. So, it belongs to A. Next, 3, y is equal to 3 plus 1 equal to 4. It is in A. So, belongs to A. Next, take 4. Y is equal to 4 plus 1, which is 5. It is in A. So, belongs to A. Next, take 5. What is Y? Y is equal to 5 plus 1, which is 6. And it belongs to A. 6 is in A. Next, take Y. X is equal to 6. Y is equal to 6 plus 1, which is 7. Is 7 in A? Can you find out 7 in A? No. So 7 does not belongs to A. So the ordered pairs are 1, comma 2, 2, comma 3, 3, comma 4, 4, comma 5 and 5, comma 6. So let us write it. 1, comma 2, 2, comma 3, 3, comma 4, 4, comma 5, 5, comma 6. These are the ordered pairs for the relation given. Now we have to depict this relation using an arrow diagram. So to arrow diagram, we need oval sheets. Okay. So this is the arrow diagram we have to represent. So it is from A to A. So what are the elements in A? It is 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. 1 is marked to 2. So mark this 1 to 2. Okay, draw an arrow. 2, comma 3. So from 2 to 3. 3, comma 4. 3, comma 4. 4, comma 5. So first element from the first set. Second element from the second set. 5, comma 6. So this is the way of representing the given relation using arrow diagram. Okay. So this is the first part. What is the second part? Write down the domain, codomain and range. Domain. What do you mean by domain? First element in the ordered pair. First element of ordered pair in relation. Okay. First element of ordered pair in relation. Who are they? 1, 2, 3, 4, 5. 3, 4, 5. So this is domain. What do you mean by codomain? Codomain is nothing but all the elements from the second set. Here the set here the relation is between the same set from A to A. So the second set is also A. So that is codomain is all the elements from the second set. So what are the elements? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. This is codomain. What do you mean by range? Range is nothing but second element of the ordered pair in relation. So what are the second element? 2, 3, 4, 5, 6. Okay. So second element of the ordered pair in relation. So second elements are 2, 3, 4, 5, 6. So these are the range for the given relation. Okay, children? Understood? So shall we move on to the next example in the next page? Yeah. Example 8. So they gave the arrow diagram for the given figure. Write the relation in set builder form and in roster form. Okay. First we will write the relation from, what is the relation? From P to Q. The set is P to Q. Let us start the solution. We have to write the ordered pairs. What are the ordered pairs? Here if you check, 9 goes to 3 and 9 goes to minus 3. Okay. So it is 9 comma 3 and 9 comma minus 3. Next take 4. 4 goes to 2 and 4 goes to minus 2. So it is 4 comma 2 and 4 comma minus 2. Next if we take 25, 25 is marked to plus 5 and minus 5. So it is 25 comma 5 and 25 comma minus 5. So this is the ordered pair for the given relation. So if you check this relation, you can see that x is the square of y. 3 square is 9. Minus 3 whole square is also 9. 2 square is 4. Minus 2 whole square is 4. 5 square is 25. Minus 5 whole square is 25. That is, relation is square of y. That is, x is square of y. This is the relation. X is square of y. This is the relation. Now what is the first question? Write this relation in set builder form. So relation is nothing but P to Q. Relation is from P to Q. What is the relation? It is set of all x comma y such that, what is the relation? X is a square of y. Okay. So x is nothing but y square. X equal to y square. So in this way you can write, or you can just write x is a square of y. X equal to y square, or x is a square of y, where x belongs to P and y should belongs to Q. So this is the set builder form. So relation from P to Q, which is nothing but set of all ordered pair x comma y. And what is the relation? X is the square of y. So you can write x is a square of y, or x equal to y square. Okay, anyone. Here x should be from P. X belongs to P and y should be from Q. So y belongs to Q. So this is the set builder form. Now we have to write it in roster form. So roster form is this. Okay, second one. R is a relation from P to Q such that, what is the relation? 9 comma 3, 9 comma minus 3, 4 comma 2, 4 comma minus 2, 25 comma 5, 25 comma minus 5. So this is the roster form. That is, first element should be from P, second element should be from Q, which satisfies the condition x is a square of y. Okay. So for only this element from Q, it has no element from P. So for 1 square, it is 1. Here, the 1 is not present in P. So 1 is not marked from Q. Okay. So this is the relation in roster form. What is its domain and range? What is domain? Domain is nothing but first element of the ordered pair in relation. Okay. So what are the first element? 9, 4, 25. No need to write the element twice. Write it only once. This 9, comma 4, comma 25. So this is the domain. What is range? It is nothing but second element of the ordered pair in relation. 3 minus 3, 2 minus 2, 5 minus 1. So these are the elements. So let us write the positive elements in an order. What are the positive elements? 3, 2, 5. So you can write it as either as 5, 3, 2 or 2, 3, 5. Okay. So let me write in descending order. So descending order, biggest number is 5. 5, 3, 2. Okay. So I wrote 5, 3, 5 is written, 3 is written, 2 is written. So next negative elements, it is minus 3, minus 2, minus 5. Okay. So which is the next biggest? It is minus 2. Next one is minus 3. Next one is minus 5. So I wrote just in descending order from big to small. Okay. So 5, 3, 2, minus 2, minus 3, minus 5. So even you can find the range from the arrow diagram. So whatever here it is marked. Here only thing 1 is not marked. So the range will be 5, 3, 2, minus 2, minus 3, minus 5. Okay. So these are the range and the domain. Here all the elements are marked. So domain will be 9, 4, 25. Okay. Understood? Okay. So let us go to the next example in the next page. Example 9. So this is the last example for relations. Let A is equal to set of all 1, comma 2 and B is equal to set of all 3, comma 4. Find the number of relations from A to B. Very simple. We know the formulas. If n of A. How many elements in A? 1, 2. 2 elements. How many elements in B? 1, 2. 2 elements. So how many elements in A cross B? It is nothing but product of these two. This 2 into 2, which is 4. So how many elements in the relations? So number of relations from A to B is equal to 2 power number of elements in A cross B. 2 power 4. What is 2 power 4? It is 16. So number of relations from A to B is 16. Okay. Understood? So these are the basic concepts involved in relations and their related examples. Okay, children? So in the next video, we will discuss about exercise 2.2. Thank you. Bye-bye.